Hi friends, welcome back to new session. In this session, in chapter number 3, Synchronous Machine, we'll discuss effect of harmonics on induced EMF and advantage of star connected armature winding. Okay, so first of all, let me take effect of harmonics on induced EMF. Effect of harmonics on induced EMF. I think we already know EMF equation of an alternator. Please try to recollect that. I'm asking formula for induced EMF of an alternator. RMS value of EMF per phase. E1 per phase. Actually, this E1 per phase value is what I can say RMS value. That's what RMS value. Please try to refer EMF equation of an alternator. There I derived E1 per phase formula. I told 4.44 Kp Kd pi ft phase. Okay. To be frank, I'm just talking about fundamental EMF per phase. So here I can take it as Kp1, Kd1, okay, pi ft phase. Right? Now, please tell me, suppose I already told you Kp into Kd. Kp means what is pitch factor. Kd means what? Distribution factor. Kp into Kd means what? It's a winding factor. Okay. So I can write this one now 4.44 Kp1 Kd1 can be written as Kw1 winding factor into the fundamental RMS value of EMF per phase. No. So let me take here phi1 per phase, phi1 ft phase. You tell me now this EMF equation, whatever 4.44 Kp Kd pi ft phase is there, this E value is what I can say RMS value per phase. Is what I can say RMS value per phase. And flux used in RMS value of EMF equation of alternator is what? It's pi1. I'm asking pi1. Average value of flux per pole. Please try to understand. This I already given in EMF equation of an alternator. Please try to refer that topic. You'll have some idea. So E1 per phase means what? RMS value of EMF per phase. So pi1 means what? Pi1 means what? Average value of flux. Average value of flux per pole. Average value of flux per pole. Okay. So this can be taken as E1 per phase. This can be taken as equation number 1. So similarly, tell me what about I'm asking nth harmonic EMF, nth harmonic RMS value of EMF per phase. I'm asking formula. Please tell me directly 4.44. 4.44 what? Kw2, Kw I can say N. So nth harmonic no? Kwn. Here it is the nth harmonic flux. Pi N. Frequency becomes N times of frequency into T phase. This is what I can say equation number 2. 4.44 Kwn pi N NF T phase. Okay. So tell me from the equation number 2. So 2 by 1 gives you what? 2 by 1 that implies what? En by E1 I'm asking. 4.44 by 4.44 it will cancel. Now Kwn by Kw1 into pi N by pi 1 into NF by F becomes N. T phase cancel. This is what I can say En by E1 equation. So this is a fundamental EMF. To be found fundamental RMS value of EMF per phase is nth harmonic RMS value of EMF per phase. Okay. So this is the equation En by E1 in terms of Kwn, Kw1, pi N, pi 1 and N. So tell me here, what is the nomenclature for this pi 1? Average value of flux per pole. This pi of same. Average value of flux per pole but corresponding to nth harmonic. Okay. Now I'm asking in terms of if I want En by E1 value in terms of B, maximum flux density. So please tell me how can you draw that? You tell me if you take one equation, one waveform of your B, you might have seen average value of flux density B average if you want. Okay, if you do this, you'll get 2 B max 1 by 2 B max 1 by pi. You will get B average. I'm saying 2 B max 1 by pi. Okay, 2 B max 1 y by 2 B max 1 by pi. Okay. Now, suppose guys, if you want pi 1. Pi 1 means, actually pi means what? I can write B into A. I can write pi equals to B into A. I can write. So what is the nomenclature for this pi 1? Average value of flux per pole. Means here A means what? Area under each pole. Area under, I can say area under each pole. Area under each pole. Please understand. This one, pi 1 means what? I can say average value of flux per pole. Average value of flux per pole. If you want B average, if you want average value, here B average into A. A means what? Area under each pole. Area under each pole. Area under each pole. So for this formula, if you want me to write B average into area, means pi dl by pole. No, for each pole is you can take here P. So D means what I can say here? Diameter of the armature. Diameter of armature. And L means what I can take here? Axial length of armature. Axial length of armature. So this is what I can say total area. But if you want per pole means I'm just taking by P. Okay. So now tell me pi 1 is equals to what is the value of B average? Here for a waveform, for a full cycle, if you see, if you want B average value, 2 B max by 1, 2 B max 1 by pi, it's very common, If you do, B average, you know how to calculate B average for this waveform, you'll get 2 B max 1 by pi. So let me calculate here 2 B max 1 by pi into what? Pi dl by P. Let me cancel pi. You'll get what? Pi 1 is equal to how much? 2 dl by P into B max 1. Similarly, tell me, I'm asking pi n value also. Pi n value how much? 2 dl by np into B max n. So these values please substitute here and tell me En by E1 value. En by E1 is equals to Kwn by Kw1 into pi value how much? 2 dl by np into B max n by pi 1 value how much? 2 dl by p into B max 1 into what? N. Let me cancel 2 dl, p, n. So ultimately you'll get En by E1 is equals to Kwn by Kw1 into B max n by B max 1. So please take this one as equation number 4. So these two equations please try to remember. Okay. I think still there is no, still now there is no question based from this in GATE. But suppose if they ask you to find nth harmonic EMF by giving a fundamental EMF and Kw1 he has given, Kw1 he has given, B max 1 he has given, B max 1 he has given. If he is asking to find nth harmonic EMF value, this is the formula you have to use. And similarly, if he has given Kwn, Kw1, if he has given pi n, pi 1, n, E1, you can find out En value from this equation number 3. Okay, please, so just note on this. En by E1 value. right? Next is advantage of star connected armature winding. Advantage of star connected armature winding than a delta connected armature winding. So I request you, before explaining this topic, before listening this topic, advantage of a star connected armature winding, you please try to see transformer chapter before starting a three-phase transformer. I think we explained on topic effect of non-linearities and saturation of magnetic core on the operation of transformer. There I told you, if you want to provide path for third harmonic currents, okay, it has to satisfy one fundamental property. But since it is not satisfying fundamental property, path will not be possible. Though fundamental property is not satisfied by third harmonic current, still path can be provided if there is closed path between phases, which is possible in delta, not in star. So these statements I told. So it may be somewhat new to you, but please, those who listened already transformers chapter, they can understand. Please try to refer transformer topics. They told you, I mean, how can you provide a path for third harmonic currents in delta connected winding? Okay, and why when there is no path for third harmonic currents in star connected winding? I just told in chapter number 1. Please try to refer that and please come to. Okay, then you can watch this video. It will be easy for you. Okay, all right. Advantage of star connected armature winding. Tell me, armature winding is what? Yeah, armature winding means what? Armature winding is the one where EMF is induced in alternator. So no. Suppose guys, if you take example, let me take a star connected armature winding like this. Star connected armature winding like this. Here see, this is what I can say: R phase, Y phase, B phase. Now you see this R phase, EMF induced in armature winding. Observe clearly. In if armature winding is star connected, EMF into generally it will be ER1 plus ER3 plus ER5 plus and so on. In Y phase we'll be having EY1 plus EY3 plus EY5 plus and so on. In B phase EB1 plus EB3 plus EB5 plus and so on. Okay. Now tell me, if I want ERY means what? ER minus EY. ER value means how much here? ER minus EY. ER1 plus ER3 plus ER5 plus and so on, minus what? EY value means EY1 plus EY3 plus EY5 plus and so on. So I think you can write like this, right? This one, ER1 minus EY1 plus ER3 minus EY3 plus ER5 minus EY5 and so on. Like this you can write. Okay. Now tell me guys, suppose you know already, suppose I'm saying ER1 value, if it is E at an angle of 0, EY1 value how much? So if I take RYB phase sequence, E at an angle of minus 120. What about EB1? E at an angle of minus 240, or I can say plus 120, whatever. Okay. Now tell me, I'm asking a question here. ER1 value how much? E at 0 minus EY1. If I take E at an angle of minus 120 plus ER3 value. So once again, let me take here ER3 value is equals to E at an angle of 0. You know already this third harmonic voltage can be called zero sequence voltages. Please try to refer the transformer topic, whatever I told. There I told positive sequence currents, negative sequence currents, zero sequence currents, also I told. Okay. ER3 Z at 0, E by 3 also E at 0, EB3 value how much? E at 0. That displays with 0 degrees. That's why this voltage can be called as zero sequence voltages, triplet harmonic voltages, cofacial voltages. Okay. So now tell me ER3 value how much? E at 0 minus, what is the value of E by 3? E at 0 plus. What about ER5 value? Solve the thing. You know guys, ER5 value if you take E at 0, E Wi-Fi value if you want, it's a fifth harmonic current can be called as fifth harmonic voltage can be called as negative sequence voltages. Negative sequence. See here, what is the phase sequence of fundamental? RYB means first R phase, next after 120 Y phase, after 240 B phase. But this phase sequence is negative. Negative phase sequence RBY means ERY after how many degrees circuit Y phase? After 240. That means you should say E at an angle of minus 240, I can say plus 120. And EB5 please. When compared to the R phase, after 120 it will come. So E at an angle of minus 120. So now tell me ER5 value how much? E at 0 minus EY5 value how much? E at plus 120 plus and so on. Now please tell me this value how much? Do you think that this since magnitude is same, do you calculate this value as 0? No. Because the angle is 0, it is minus 120, this value will not become 0. To be frank, some value will be there. I can take this value as EL1 plus, what of this value is 0? Because E at 0 minus E at 0 is 0. Now what about here? E at 0 minus E at E at plus 120, it also will not become 0. To be frank, it is regarding fundamental, it's regarding third harmonic, it's regarding fifth harmonic, no. So I can call it as EL5 plus and so on. So please observe guys here one small thing. This one small thing. In the stark armature winding, though third harmonic voltage exists in a phase ER3, E by 3, E by EB3, but what about in line? Those are not present. They'll cancel with each other because that distance 0 degrees. They'll cancel with each other. That point is very important. Okay. So ERY is equal to, if you see, EL1 plus 0 plus EL5 and so on. So what is the conclusion here? I can say, though third harmonic voltage exists in a phase, what about in line? They will not be present. That's a very important point here. Okay. And now please, here one thing I want to say here. First of all, let me take M gamma 60 degrees. M gamma 60 degrees. Tell me, I'm asking you a simple question. Tell me in a 60 degree phase speed, if I want E phase RMS value, I'm asking. What's the formula? Square root of, observe guys clearly, square root of E phase 1 square plus E phase 3 square. Observe guys, in star connect, in the phase, thermal voltages are there. Therefore, I can write a square root of E phase 1 square plus E phase 3 square plus E phase 5 square plus and so on, right? Now tell me what about line what I am asking? E line to line RMS I am asking. For 60 degree phase speed I am asking line voltage. You know star connection line equals root 3 times the phase voltage, right? Root 3 into phase voltage. While writing the line voltages, you should not show third harmonic voltage here because it is cancelling, no. So simply you should write root 3 into square root of E phase 1 square plus what? E phase 5 square plus and so on. Very important. Please take this one as equation number, whatever we wrote line value, you just take this one as equation number 1. Is it clear? So what is the conclusion here? In the stargate armature winding, though thermal voltage in phases, but in line they will disappear. That's why E phase RMS equals square root of E phase 1 square plus E phase 3 square plus E phase 5 square and so on. But whereas in line, if it is root 3 times of square root of E phase 1 square plus E phase 5 square, I don't have a third harmonic EMF here because of this concept. Now tell me, what about for M gamma 120? M gamma 120. M gamma 120. You please try to see one topic which I told in distributed winding. Among narrow phase bed and wide phase bed, M gamma 60 degrees is narrow phase bed. M gamma 120 means wide phase bed. Among narrow and wide phase bed, generally narrow phase bed will be preferable. I told, okay, because in narrow phase bed, phase voltages, kV rating, output power will be more than that of 120 degree phase bed. But sometimes you should go for wide phase bed. M gamma 120 you should keep. Why means, suppose if you want to eliminate triplet harmonic voltages in phase itself, we should take M gamma equals 120. You know, we might have seen one formula is there. Please try to refer distributed winding topic. There I told M gamma equals to 360 by K. N I wrote this. M gamma to eliminate nth harmonic I told on formula. This formula please try to refer distributed winding topic. M gamma phase spread to eliminate nth harmonic 360 by N. Okay. To eliminate triplet harmonics. Example, if you want to eliminate third harmonic, 360 by 3 how much here? 120. Yes. Generally you just see, though triplet harmonic voltages are there in a phase, it will not be there in line. There is no need to bother about triplet harmonics. Suppose if you want to eliminate in a star connection in phase voltage itself, in phase only if you want to eliminate, at that time you should keep M gamma equals to 120. Please try to understand. You mean, suppose if you see here, though triplet harmonic voltages are there in a phase, in line, I'm not having any triplet voltage. Okay, therefore there is no need to bother. Like example, in one generation station is there, in that alternate is there, it is star connected. Generally, we'll be keeping M gamma equals how much? 60 degrees. Why? I told you, phase EMF will be more, output power will be more, kV rating will be more. So you may get one doubt, sir, because of M gamma 60, you are having a triplet harmonic voltage are there no in the phase. Let it be. Because what about a line? After coming to line, it is not, harmonic voltage is not appearing here. We are transmitting line voltages. After generation, we will step up that voltage, okay, by using transformer, we will transmit the line voltage, not phase voltage, right? So obviously in line, we don't have any triplet harmonic voltage here. Triplet harmonic voltage is not there in line. Therefore, no problem. Generally, we won't think about, we won't bother about triplet harmonic voltages. Suppose if you want to eliminate those triplet harmonics also in a phase itself, at that time M gamma equals 120 you have to keep. So if you keep M gamma 120, if you see here, M gamma to eliminate third harmonic 360 by 3, 120. That means you should understand one small thing here. M gamma 120 if you maintain, in a phase also third harmonic voltage will not be there. So now tell me, E phase RMS value how much? E phase RMS value how much? Square root of, please, E phase 1 square plus what? E phase 3 will not be there. I told now, M gamma 120 because of that, triplet harmonic voltage will not be present in a phase also. Okay. So E phase 1 square plus E phase 5 square plus and so on. Now what about line? E line to line RMS is equals to root 3 into square root of E phase 1 square plus E phase 5 square plus and so on. Let me take this value as equation number 2. So please here, I am just going to give you a point here. Because of M gamma 120, what I can say? Triplet harmonic voltages, reduced in what here? Phase voltages. Triplet harmonic voltage reduced in phase voltages. Okay. But people may think, sir, then it is better to use M gamma 120. No. What I said, you can eliminate this, though you can eliminate triplet harmonic voltage and phase voltages. But what about if I maintain M gamma 120, phase voltage of your alternator, okay, will be reduced, and kV rating will be reduced, output power will be reduced, and one more thing, did you know? I told you already in previous video, because of keeping M gamma 120, okay, so there short pitch winding will not be possible. Generally, will be the double layer winding. In double layer winding, if you keep M gamma 120, short pitch winding will not be possible. If short pitch are not possible, we cannot eliminate 5th, 7th harmonics. So generally we will be using M60 only. No problem, let it be here. But it coming to line, it will not be there. Okay. Suppose if they ask you to eliminate, if you want to eliminate triplet harmonics in phase voltage itself, this is the, M comma 120 you have to maintain. So here phase also, you cannot able to see third harmonic EMF, and line also you cannot able to see third harmonic EMF. Now tell me guys, I'll ask a simple question. Do you think that this equation number 1 and equation number 2 values are same? No. Don't say that formulas are same. Root 3, okay, root 3, square root of e phase 1, e phase 1, e phase 5, e phase 5. Yes, I mean to say that here in line, thermal voltage will not be there. Further, I just wrote the formula like this. In this M 120 also, in line, thermal EMF will not be there. That's why I just wrote like this. But what about this phase voltage? E phase 1 value in a 60 degrees when compared to wide phase spread 120, it's more here. This E phase 1 is more than this E phase 1. E phase 5 is more than this E phase 5. So obviously 1 is not equal to 2 here. I can write here 1 is not equal to 2. Since I can write phase voltage is more in what? Is more in M gamma 60 degrees than that of M gamma 120 degrees. Okay. So please try to understand this point. Okay. Just note down. Okay. Now see our heading is advantage of star and armature winding than delta connected. So for explaining that statement, first of all, let me ask a simple question. Excuse me. In this star connection, everybody, in this star current armature winding, I am saying in phases, you got ER3, EY3, EB3. You got ER3, EY3, EB3. Tell me, because of this ER3, EY3, EB3, do you have any circulating currents here? Please, here is very important point. Just understand. ER3, EY3, EB3. Because of this ER3, EY3, EB3, do we have any circulating currents here? Circulating currents, or I can say IR3, IY3, IB3, like that. Do you have any currents here? No. Because of ER3, EY3, EB3, I don't have any harmonic currents here. I don't have any circulating currents here. What is the reason? Since There is no closed path. There is no closed path between. There is no closed path between phases. Between phases in star connection. Is it clear? Since there is no closed path for harmonic this harmonic current for circular current, therefore IC will not flow. Whenever circular currents are not flowing, so what about no? Do you have any heating effect here? No heating effect. No heating effect in the winding. No heating effect in winding. No temperature rise in the winding. No temperature rise in winding. No temperature rise in winding. Suppose all these things will happen in no heating effect, no temperature rise, no IC. But in delta current, if you take delta connected, there circulating currents will be there, and heating effect will be there, and temperature rise will be there. Let us see. Now instead of taking star connected, if you take delta connected now, if you take delta current armature winding, so please take delta current armature winding like this, armature winding in delta connected like this. Let's see R phase, Y phase, B phase. See, as I told you previously, in armature winding, if it is star connected also, what are the EMF induced in phase? ER1 plus what? ER3 plus what? ER5 plus what, and so on, right? And similarly, what about here? EY1 plus EY3 plus EY5 plus, and so on. What about here? EB1 plus EB3 plus EB5 plus, and so on. Yes or no? Now tell me. In previous case, because of this ER3, EY3, EB3, I don't have any circular currents here. Why? There is no closed path between phases. But here, because of this ER3, EY3, EB3, you will be having circulating currents here. Circulating currents will come into picture. Or I can say IR3, IY3, IB3 will come into picture here. That's important, okay? Because of that, delta 1 general will not prefer. Because if there is closed path for circulating currents, so obviously temperature will be there, heating effect will be there, no? So that's the reason I should not use, okay? Anyway, let us see one thing. I'll ask a simple question here. In this case, guys, what is the E phase RMS value? E phase RMS value. Previously, what you wrote formula? Square root of, listen, square root of what you said? E phase 1 square plus what? E phase, please try to see this star cut armature winding for m gamma 60 degrees in phase value. You told square root of E phase 1 square plus what? E phase 3 square you told. But now we won't get 3 phase here. I'll tell you what is the reason. E phase 5 square will come, and so on. That will be equal to what, ma? E phase RMS will be equal to what? E line to line RMS. E phase RMS will be equal to E line to line RMS. What is the reason? Since delta winding. So now let me ask a simple question. Why harmonic EMF is not appearing there? Very simple. Because of this ER3, EY3, E by EB3, we will get IR3, IY3, IB3 will come into picture. Like I said, these currents can be called as circular currents will come into picture. Okay, circular currents will come into picture. What is the reason? Since closed path exists between phases. I'm saying between phases. Okay, closed path exists between phases. So because of this IR3, IY3, IB3, you will have some flux will come into picture. I can call it as the pi R3 dash, pi Y3 dash, pi B3 dash. Some flux will come into picture. Because of this flux, you'll get ER3 dash, EY3 dash, and EB3 dash. This ER3 dash will cancel with this ER3 will cancel with this ER3 dash. This EY3 will cancel with the EY3 dash. EB3 will cancel with the EB3 dash. Therefore, I will not have any third harmonic voltage in delta connection. Observe guys clearly. Third harmonic currents will be there, but third harmonic EMF will not be there. Because of third harmonic EMF, third harmonic currents will come. Because of this current, E3 will come. This E3 will cancel with the E3. So third harmonic EMFs will not be there, but third harmonic currents will be there. Please try to understand this small logic. Third harmonic EMFs will not be there, but third harmonic currents will be there. I mean, circulating currents will be there. Okay. So that's the reason I did not show third harmonic EMF in this phase is equals to line. Okay. Just note on that. And after that, let me give formula for circulating currents IC. First, complete this one. Right. Now, please tell me what is the formula for circulating currents. First of all, tell me circulating currents corresponding to ER3, EY3, EB3. Tell me. IC is equals to. You know, guys, ER3, EY3, EB3 are displaced by how much? 0 degrees. Example, let me take ER3 value E3, EY3 value E3, EB3 value E3. Is it clear? ER3, EY3, EB3, because of this you are getting circulating currents. No, IC if you want, these voltages are in phase because that is 0 degrees. Therefore, E3 plus E3 plus E3, how much? 3E3 by 3E3 by 3E3 by. Here, thermic reactance X3, X3, X3. I can say here 3 times of X3. Let me cancel 3, 3. What is this value? E3 by. So what is the value of X3 value I'm asking? So E3 by, what is the value of X3? You can write here 3 times of X1. The reactance means what here? 2 pi F. Harmonic I'm saying. So F becomes 3F. So 3 times of X1. X1 means 2 pi F L. X3 means 2 pi F L only, but F becomes 3 times. So it becomes 3 times X1. Okay. So now IC equals what I got here? E3 by 3X1 you got. This is what I can say in the circulating currents due to third harmonic. See, triplet harmonics not only third, no, you will be having 3 is there, next 3, when 3 into odd number, 3 ones are, 3 threes are, 3 fives are, 3 sevens are, and so on. These can be called as triplet harmonic. These harmonics can be called triplet harmonics. Okay. Now I am asking circulating currents in general due to triplet harmonic voltages means this corresponds to 3, right? E3 by, you are saying 3X1. Very good. Next, what about next one? E9 by 9 times of X1 plus E15 by 15 times of X1 plus and so on. So this is the formula for circulating currents. Just note out. E3 by 3X1, E9 by 9X1, E15 by 15X1 plus and so on. Yes. Now tell me, our last conclusion, our heading here. Advantage of star cut armature winding is no. Now tell me, what are the advantages? Number one. Please tell me, what is the advantage here? I can write here. There is no closure path. I can write here. Please see, statement number one. I can write here. Advantages. There is no closure path. There is no closure path for what? There is no closure path for. There is no closure path for circulating currents in star connected armature winding. That is the first point. Second advantage, please. Whenever there is no closure path for circulating currents, obviously what will see circulating current path is there in a delta. Advantage of star means what? I don't have a path for circulating current. That is what I can say one advantage, because there is no closure path for IC in star connected armature winding. There is no closure path for IC between phases. Between phases in star connected armature winding. Second one, no heating effect. Third one, no temperature rise. Okay. Next one, tell me what is the one more advantage. These are the advantages, right? These are the advantages. Advantages of star connected armature winding. Number one, no closure path for circulating currents between phases in star connected armature winding. Number two, no heating effect because there is no path of circulating currents. Number three, no temperature rise in winding. Okay. Number four, tell me number four, what is that? Since in a delta winding, there is no neutral, right? There is neutral, but in star, neutral we can provide. Therefore, safety will be there. Okay. So in this advantage of star connected armature winding, since there is neutral, it is safety. It is safety. And in addition to these points, I can give fifth point also. What is the fifth point, please? Fifth point. Example, guys, you just assume if delta is there, suppose star is there. In generalization, if example alternator is delta connected, in alternator phase voltage, example, let me take 230 volts. I'm just example I'm saying. Okay, 230 volts is the phase voltage induced in alternator. If alternator armature winding is delta connected. Okay. Now what about line voltage here? Same 230 volts. No. Suppose in star connected, same example, if phase voltage in that alternator generated value is, if I take 230 volts, what's the line voltage? √3 into what? 230. So what is the conclusion here? Suppose if you take same phase voltage in the star and delta, in star line voltage is more. Because of that, what is the advantage? It's very simple, no? Suppose when generation is there, after generation, you are giving that line voltage to step up transformer. Why? For step up with that voltage, so that we will transmit high voltage. Transmitting high voltages, already we know. If I transmit high voltage, P equals to √3 VL IL cos phi. If I transmit for a constant power, if you transmit a high voltage, current will be less, loss will be less. That everybody knows that. Okay. So in star connection, line voltage is more, no? That means if armature winding is star connection, line voltage is more. That more line voltage is giving to step up transformer, you will get somewhat more line voltage. So line voltage will be more, so that transmission of high voltage is more economical because loss will reduce. Suppose if you transmit this one, if alternator is in delta connected armature winding, line voltage 230 only. So obviously line voltage will be less. Transmitting 230 is not economical than transmitting √3 into 230. So transmission voltages are more if armature winding is in a star, not in delta. So note on that point, fifth point here. So transmission voltages are more if armature winding is in star connection. If armature winding is star, okay, transmitting high voltage Transmitting high voltage, transmitting high voltage, transmit high voltage is more economical, is more economical, is more economical if you compare transmitting of low voltage. Okay, transmitting high voltage is more economical. This point everybody knows that transmission voltages are more if armature winding is star, because in star connection line voltages are more. Okay, so that's the reason. So I can write here in star connection. What is the reason, man? Since transmission voltages are more if armature winding is star connection, you can write here since line voltages are more, line voltages are more, line voltages are more if armature winding is in, line voltages are more if armature winding, if armature winding is in star connection, if armature winding is in star connection. Line voltages are more if armature winding is star connection. Therefore, transmission voltages are more because line voltages are more in if armature winding is star connection. Transmitting high voltage is more economical. These points you should understand. Okay, this is not